Hello guys, welcome to this continuous integration with Jenkins Hudson series. Actually, I have been working on this continuous integration for more than 3 years now, but I don't see any effective material in the internet which talks about continuous integration with Jenkins or Hudson end to end. So I thought of doing a series on it so that it might help others. So that's why I started this. Okay, that's the story. So to move to what is continuous integration. Continuous integration is actually a very important software engineering practice which is followed in big enterprises to make the build process much faster and things. We will just see what is continuous integrations and what are its principles and stuff. Okay. So first, what Wikipedia says about continuous integration. Okay, continuous integration is the practice in software engineering of merging all developer working copies with the same shared mainline several times a day. Okay, whatever it is, but it's not only merging of all developer working copies. It's more than that. Okay, but what generally continuous integration practice follows is like, first it will check out all the codes whatever the subversions has. Okay, what the developers committed to the subversion, it will first check out the code, and depending on the project type, it will perform the build on top of it. Okay, it will do the automated builds. Once done with the build, if there is some test cases need to be run on that, sorry for this. So based on the project, if test cases need to be run, then we can enable the test cases and we can run the test cases, functional test cases, unit test cases. Those things we can just apply on top of your build process. Okay, and you can also automate it, your deployments through your build tools. Okay, and you can do everything end to end from your continuous using your continuous integration practice. Okay, so to move about continuous integration principles, you will maintain your code in your repository. That is the first principle. We'll have a subversion where we'll maintain the code. When any changes happen to the code, then automatically a build can be triggered if there is a file change in specific path of your subversion. Okay, and you can enable the automated build if something changes in the code repository. And we can also enable the test cases. As I mentioned earlier, you can just enable the test cases, and yeah, every commit is required, and if builds need to be triggered for every commit, then that is also possible with the continuous integration practice. And yeah, so keep the build fast, so it should run fast and it should complete all the necessary steps which is required to be completed. And before moving the code to the production environment, it need to be tested thoroughly in your testing environment. Then the tested code alone will be moved to the production environment. So we are just mentioning that as a principle in CA. And once they're done with the build, if the build is successful or failure, we need to publish the results to the developers, right? So that is one of the primary principles of CA. So that is one another practice, and we can also do automated deployment to your application servers or web servers if it is required. Okay, so that is yet another CA principle. And how the life cycles is managed in continuous integration practice. Okay, the very first step, you can just note it down. So the very first step is that your development team commit their source code to the version control system, for example Subversion or Git or any other Subversion system. Okay, on top of, so once we checked out the code, we have to do a build. For example, if it is a Java project, we have to convert all your Java files to a class files, and you have to build your certificates. For example, whether it is in jar or var or er, those certificates need to be applied. So, okay, that is the source code build section. Static code analysis, for example, you want to detect any programming errors or programming warnings or something, then you can apply your analysis tools on top of this source code. For example, PMD find bugs, programming mistake detector tool, or find bugs can do those kind of statistical code analysis on your code, and you can run your automated test cases as well along with this. Okay, these are the list of principles, right? Whatever it's there in the previous slide, that's what it is all about. So run automated unit test cases. Maybe you can use it, try to using JUnit library API, and you can also do code coverage analysis things. And once everything is done, you can do a certificate of your build files for whatever I mentioned earlier, right? So jar, var, AR, and those things. Once it is done, you can just deploy the code to your test environment, and once the code is deployed and it is up and available, you can access the application. For example, if it is a browser application, you need to access the application through the browser, and you have to run some functional test cases. Then that thing can also be run using Phantom.js or Selenium or something like that. You can just run it through Hudson, and once it is done, you want to publish the results again to the development team or stakeholders, some other stakeholders. Then that is also possible with this continuous integration practice. Okay, so in this continuous integration series, exactly which software we are going to use. Okay, the maximum percentage of people using CI server is Jenkins Hudson based server. Actually, Hudson is the parent build, whereas Jenkins is derived. I don't know, not exactly know that. It is 2011 or 2012. Jenkins is cloned from Hudson's repo, and it is now maintained exclusively by Oracle. Okay, so in this series we are just going to see everything with Jenkins, but there is no major difference between Jenkins and Hudson, as this is a similar code base. And Bampo is occupying 7% of it, and TeamCity is occupying 5% of it, and Cruise Control is having a market of 4%. Okay, these are some of the CI servers, but CI servers cannot act all alone. Okay, it needs some build tools to do some necessary builds. If you take in Java, a build need to be happen. For example, some compilation need to be performed. Okay, to make your job a lot more easier, there are three main build tools available in the market. One is the famous Apache Ant, which is built on top of Make, and Maven, a centralized repository which it's have, and a Gradle. Okay, which is, I think it's introduced in the market around 2012 or 2013, and which is quite famous nowadays. And these are we are just going to use Apache Ant in our series, and we will also use Maven whenever it is required. Okay, that's it. I hope I covered all the necessary things, what a CI server is all about, and what are its principles, what is its lifecycle is all about, and which continuous integration software which we are going to use in this series. Okay, if you take a look at the comparison of continuous integration software from wiki, and this is what is allowed. Okay, it have some various softwares, but the most famous one are like as I mentioned. So Jenkins and Hudson is the one famous one, and other than this we have Travis CI, which is also quite famous nowadays, and TeamCity, Team Foundation servers, and the Cruise Control. Okay, so these are some of the famous continuous integration softwares which is available in the market today. So you can just visit this link and you can get to know about what is continuous integration practice is all about, what are the list of softwares which is helping us to achieve this practice continuous integration. Okay, That's it for the session. See you in the next session, and briefly about installing, how to install Jenkins, how to proceed further. Those things we will see in a while. Okay. Thanks for watching the session. I'll see you in the next session.